Okay, here is your Chapter 7 test review sheet. Just wanting to give you some help with this. So let's jump right in and get this started. Problem number 1, as you can see, we are simplifying these two fractions that are being multiplied together. So that involves factoring as much as we can. So everything, this left fraction is already factored. So let's work on the right side. The numerator would factor, first of all, factoring out -1 would allow me to switch places with these two terms, make it become k squared minus 1 times -1. And then I can factor k squared minus 1 using the difference between two squares. So the -1 is still a part of the factoring, but I'm going to factor k squared minus 1 as k plus 1 times k minus 1. All right, so I'm just going to mark this one out since it's been factored more. Still got the -1, so my numerator really becomes -1 times k plus 1 times k minus 1 in factored form. And the denominator in factored form will be k minus 3 times k minus 1. So the idea now is to look at matching factors either diagonally between the two fractions or vertically within a fraction, and matching factors will cancel. So for example, going diagonally, I can cancel these k plus 1s. Going diagonally again, I can cancel these k minus 3s. And vertically within the fraction, I can cancel k minus 1. And so as you can tell, everything canceled except for -1. And so that ends up being my answer for this first problem. All right, this is a division problem, so ultimately I'm going to be flipping this second fraction over and it's going to turn into multiplication. So it's still true that I need to factor everything that is factorable. So this numerator would factor out using 2 as a GCF, 2 times d plus 3. Below that, I could factor using the factors of -2 that add up to +1. That would be d plus 2 times d minus 1. And once again, division needs to be turned into multiplication. Okay, so there's my multiplication symbol. And then I'm going to flip this fraction over. So factoring d squared plus 3d plus 2, I'm going to use the factors of 2 that add up to 3. So I took that denominator and put it on top. And then this numerator goes to the bottom. It's already prime, so it doesn't factor. So let's mark those out since we're not using those. And now we're back to the same type of problem that we had over here. We look for matching factors. So notice I've got matching d plus 3 factors going diagonally, d plus 2 going this way. Doesn't look like anything else cancels, so my final answer will be everything that doesn't cancel. 2 times d plus 1 will be my numerator divided by d minus 1. And when you're taking your test, you don't have to worry about doing the distributive property. You can leave your answers in factored form. Okay, here's another really division problem, just like the previous one. We're dividing by this fraction, so that means we're going to have to flip it over and turn it into multiplication. And we still factor everything that we can. So this problem really could be rewritten as times b squared minus a squared over x squared minus y squared. So dividing really becomes multiplication by the inverse. Okay, I'm just going to mark that out. And now we have a multiplication problem. So we got a factor. So I'm just going to come over here and got plenty of room to work over here. The first fraction can't be factored, but the second fraction, both numerator and denominator, can be factored. If I factor out -1, like we'd had in our previous problem, we can reverse the order of these terms. And then we'll come back to that in just a second. You'll just do this one step at a time. So far all I've done is factored out -1, so I could change the order. And now I'm going to factor the difference between two squares in both cases. So this is going to become a plus b times a minus b. Still got the -1. And this is going to be x plus y times x minus y. Okay, now let's see if we have some matching factors that we can cancel. Like diagonally, I can cancel these a plus b's. Diagonally this way, I can cancel x minus y. Doesn't look like anything else cancels, so be careful that you notice everything that doesn't cancel and let that be part of that will be your answer. So -1 times the quantity a minus b, and that's divided by x plus y. And that's okay if you want to leave it like that, but usually with -1, I think we should just go ahead and distribute. If you happen to forget, probably wouldn't cost you anything, but I think this is a better way. When -1 is the factor, just go ahead and distribute it. But I would accept either one of these. All right, and that's your answer for number 3. Number 4 and 5, we get into addition. So we've been doing multiplication and division. Now we're going to be doing addition and subtraction. So for addition and subtraction, we can't add or subtract two fractions unless they have the same denominator. So a method that we use to come up with the least common denominator is by doing prime factorization. So the prime factorization of 8c squared d squared would be 2 times 2 times 2, that's 8, c times c, d times d. So that's the complete prime factorization of that denominator. And now we'll do the same thing with the other denominator, 2 times 7. You've got 4 c's and a d being multiplied together. Okay, so notice any common factors, like I have common 2 here, so I need 1, 2 to represent this common pair of 2's. Okay, so I don't need 2 twice, I just need one factor to represent matches. All right, I don't see any other number matches other than this pair of 2's, so the other the other prime factors I'm just going to list. Okay, 2, 2, 7. So here's my common 2, and then the other 2 2's to go along with 7. All right, now let's work on variables. So I notice a common pair of c's here, so there's a c to represent those. Here's another common pair of c's, so here's another c to represent those. These two are not common, so I just list them. Okay, common, common, 2 not common. And then let's mark those out. And then I've got a common pair of d's to go along with this, called an orphan d. Okay, so we put all that together, and that helps us come up with the LCD. And I'm going to write that LCD really twice, because I'm about to create two brand new fractions that are going to be equivalent to these, but they're going to have the same denominator. So if you notice, we got 2 times 2 times 2, that's 8, times 7, that's 56. C, there's 4 c's, so that's c to the 4th. And 2 d's, that's d to the 2nd. So that's my lowest common denominator. We're at the 6, 56. Oh, I guess the 6 just did not write all the way. 56, c to the fourth, d to the second, c to the fourth, d to the second. All right, so once you understand how to get the LCD, then you divide, okay? Take your original denominator and divide it into our new LCD. And 8 goes into 56 7 times. C squared goes into c to the fourth, c to the second time, and the d squares would cancel because they match. So I take that 7c squared and I multiply it times, so it's like 7c squared, which is what I got when I divided, and I'm going to multiply that times y squared. And I get 7c squared y squared. Okay, same thing here. Take this denominator, divide into the LCD. 14 goes into 56 4 times. The c to the fourths would cancel, and d goes into d squared d times. So 4d is the result of the division. And so now I multiply. 3x times 4d is 12dx. Okay, now you're ready to put these two together. Okay, so you've got a common denominator. So you know this is going to be the denominator of your answer. And the numerator is going to be these two combined. Now, we don't have any like terms, so the best we can do is show that these two are going to be subtracted. Can't combine any like terms in this case, but we can show the subtraction of the two terms. So there's my answer for number 4. All right, here's number 5. To get the LCD over here, remember we did prime factorization? Well, we're going to be doing prime factorization here as well, okay? It's just that with these, we have a method when it's a trinomial where the number in front of x squared is bigger than 1, we typically use the box method to help us, okay? So for those of you who maybe don't remember the box method, or you may need a little box method review, here's how it works. First term up here, last term in the bottom right, so diagonally across from each other. Multiply those together and see if you can come up with the factors of 8x squared. In this case, that add up to 9x, and that's not too bad. That's 8x times 1x. Fill in the other two squares, doesn't matter where you put those, and now find the GCFs of both rows and both columns. So the GCF of the top row would be 4x, and the bottom row would be 1. So that tells me that one of my prime factors is 4x plus 1. Going this way, the GCF would be x, and this way would be 2, and that's my other factor. Okay, and so over here, I notice that there's a GCF. Always look for GCF first. That may allow you to avoid having to use the box method. Notice factoring out a GCF of 2 gets me to where I don't have to use the box method. I can just look in the parentheses and find the factors of -12 that add up to -4. And that would be -6 and +2. Okay, so now that we've got these in factored form, it makes it easier to identify the least common denominator. All right, so I'm going to see if we have any common factors. I notice that we have common x plus 2's, but nothing else is common. So my LCD is going to be made up of these factors. I've got 2, don't forget the 2, 4x plus 1, x minus 6, And then x plus 2 is common, so I don't need to write it twice. Just like over here, when we had common factors, we just had one number to represent the match, and that's what happens over here as well. Okay, so just like we did over here, I found the LCD. I'm setting up two different fractions having the same denominator. And now I'm going to do that division process. So I'm going to divide. And basically you can look at it this way. Whatever doesn't match is going to multiply by 2x. Okay, so 4x plus 1 cancels. X plus 2 cancels. The parts that don't match, the factors that don't match, are 2 times x minus 6. So if you want to, I would suggest you just go ahead and make that become 2x minus 12. Okay, and so this numerator is going to be 2x times 2x minus 12. And that's going to be 4x squared minus 24x. Okay, now let's jump over here, and similar situation, the 2's would cancel, x minus 6's would cancel, x plus 2's would cancel. So the part that doesn't cancel is 4x plus 1. That multiplies by 3, and that would be 12x plus 3. All right, move down just a little bit, and now we're ready to show our final answer as one fraction. Do not try to factor and cancel here and here before you put these together. You need to, at this point, you need to go ahead and combine like terms in the numerator. So we just have one x squared term. We have two x terms that we can put together, so that would be minus 12x. And then I've got a constant plus 3. And all of that's going to go over 2 times 4x plus 1, x minus 6 times x plus 2. Okay, and then if you can cancel, if it's possible to cancel this numerator, it's a good idea to do that now so that you could possibly reduce. But if you notice, before you just jump right into the box method, you could go ahead and multiply 4x squared times 3. This is what you would do in the box method. That would be 12x squared. Okay, so let's just see if the box method would even be worth our time. 12x squared. Now I need the factors of 12x squared that add up to negative 12x. Well, you can probably see that there aren't any factors of 12x squared that add up to 12x. The factors of 12x squared would be 12x and x. Now both of them have to be minus. So negative, it doesn't really matter. Negative 12x, negative x. That's not going to add up to negative 12x. Negative 4x, negative 3x, negative 6x, negative 2x. I think we've exhausted all of the pairs. None of those add up to negative 12x. Remember, they have to add to the middle. So factoring isn't possible, so there's no need to try the box method. We are done with this answer, so I'll go ahead and circle it. And let's move on to number 6. Very similar type problem, except it's subtraction. So we still need to factor. So let's factor first. 3 is a GCF. Always look for a GCF first. Makes other factoring so much easier. Okay, so I factored out 3 as a GCF, and now I'm going to factor this as using the factors of negative 6 that add up to positive 1. That's plus 3 and minus 2. All right, so I've got the factoring of that first denominator, and now the factors of the next denominator. Once again, I'm going to use the good old box method. 2x squared 15, that's 30x squared. Factors of 30x squared that add up to 11x are 6x and 5x. find your GCFs, 2x and 5, so there's a factor, 2x plus 5. And x, and going this way, would be 3x plus 3. And you could check yourself out using FOIL. All right, so now that I've broken it up into factors, I can come up with a lowest common denominator. Okay, so let's see. They have a matching pair of x plus 3's, and that's it. So I've got 3. Here's my matching x plus 3 factor. Just need one of those combined with x minus 2 and 2x plus 5. All right, so this becomes my least, or sometimes called lowest, common denominator. Okay, now we do the division. So old factor denominator into the common denominator. Notice what matches, or maybe notice what doesn't match. Either way, the part that doesn't match gets multiplied by 4x. So 2x plus 5 is the part that doesn't match. That's the factor that doesn't match. So when I multiply those together, I get 8x squared plus 20x. All right, jumping over here, 2x plus 5 cancels, x plus 3 cancels, 3 times x minus 2, and I'm going to go ahead and make that 3x minus 6. Doesn't cancel, 3x minus 6, and then I'm going to multiply that by 2x. Okay, since I'm need a little bit of space to work, I'll just erase my box method work over here. And now we're ready to put these two together. So combine like terms, 8x squared minus 6x squared is 2x squared. And be careful with subtraction. Remember, we've talked about this many times. You might want to consider putting parentheses around the second numerator, because this is really going to be minus negative 12x, which is addition. So 20x plus 12x is 32x. Okay, and eventually this numerator is going to be over the common denominator. I'm going to go ahead and factor first, put it in factored form. I see a GCF of 2x. I can factor out 2x, and that becomes x plus 16. Now that I'm fully factored, I'm going to put my LCD here on the bottom. And wasn't able to cancel anything as a result of that factoring, but it's always good to make sure you don't leave an answer that could be simplified. You lose points if it could have been simplified and you don't. So always train yourself to factor if possible. All right, and so there's our answer for number 6. Okay, number 7 is a reciprocal function. Notice there's a constant in the numerator, and then we have our variable x in the denominator. So the parent reciprocal function is this. And what this is doing is taking the parent and shifting it 1 to the right. So if you remember from our discussion, this is lesson 7.3, the parent has a vertical asymptote, which is the y-axis. Well, if I shift the parent 1 to the right, that moves this vertical asymptote here to the line x equals 1. All right. And so I moved 1 to the right, and this indicates a shift of 1 up. So we take the original parent horizontal asymptote, which is the x-axis, and we shift it up 1. And now we're going to do a table for the parent, which we already indicated is this, and we're going to plot those points from here, where those two asymptote lines cross each other, because what we've done is we've just taken the entire graph, which did have its center here, the origin was here, and as the graph shifted one to the right and one up, that took our origin and moved it here. And so we're going to plot our points. Let's come up with those points first. If x is 1, y is negative 1. If x is 2, y is negative 1/2. If x is 1/2, y is negative 2. And I'm going to plot these points from this. This is my new origin. Okay, so 1, negative 1 would be right there. Okay, starting here at my new origin, 1, negative 1. Okay, back here to my new origin, 2, negative 1/2. Not making my points aren't showing up really good. And then 1/2, which would be right there, negative 2 would be right there. Okay, and we follow the horizontal and the vertical asymptotes forever, always approaching, never touching. And then whatever you choose for positive inputs, just turn around and do the same as negatives. Okay, so I'll just show it like this. If you change this to negative 1, you get positive 1 output, negative 2, positive 1/2, negative 1/2, positive 2. All right, so let's plot those. Again, from our new origin, negative 1, 1, be right there. Negative 2, 1/2 would be there. And negative 1/2, 2 would be there. And we have this curve, always approaching, never touching our asymptote lines. All right, and so that's it. That's all we had to do for number 7. Let's go to number 8. Number 8 is an example of a rational function. And so for these, we have a process. It's really like a 3-step process. The first one involves finding zeros. And I'm going to put a little note here. Make sure you do that after factoring and canceling. So make factoring and canceling part of this first step. All right, so the numerator doesn't factor, but the denominator does. You can use the factors of positive 2 that add up to negative 3. So there's my factoring, and after canceling, I'm going to end up with the graph of 1 over x minus 1. Okay, so zeros would be numbers that make the numerator 0 after, notice, after doing factoring and canceling. Well, after factoring and canceling, I end up with a constant in the numerator, and that's never going to be 0. So that tells me that I'm never, if I don't have zeros, that means I'm never going to cross the x-axis at any point. All right, so we can move on to letter B. In letter B, step 2, we're looking for vertical asymptotes, horizontal asymptotes, holes, and let's see if we have any of those. Well, vertical asymptotes, and again, you can look at the factored form. I think it's the best place to look, and look for numbers that only make the denominator 0. You might be thinking, well, 2 makes the denominator 0, but it also makes the numerator 0. So that's not a vertical asymptote. A vertical asymptote is a number that would only make the denominator 0, just the denominator. And so we have one at x equals 1. Okay. Let's go ahead and draw that. So here's x equals 1. We have a vertical asymptote here. So I can make that bigger without scrolling. So that'll be good enough. All right, now let's talk about horizontal asymptotes. And horizontal asymptotes is where we compare the degrees. Doesn't really matter which one you look at. The degree of the top is 1 in the original, the degree of the bottom is 2. Okay, bottom is bigger. If you were to happen to look over here, the degree of the top is 0, the degree of a constant is 0, and the degree of the bottom is 1, so it's still bigger. Bottom is still bigger. So whenever the bottom degree is bigger than the top, you're going to have a horizontal asymptote of y equals 0. And that's just another way of saying the x-axis. Okay, holes out. You'll have holes when you're able to cancel. And the number that makes the canceled part, the canceled factors equal to 0 represent a hole. And so if you notice 2, x equals 2, would make these canceled factors equal to 0. So I'm going to have a hole in my graph at x equals 2. Okay, and we can go ahead and do that now. Go ahead and substitute 2 in for x and see what comes out. So if you put 2 in for x, 1 over 1, when x is 2, the output is 1. So we know that when we do our graph, we're going to have a hole in it at the point 2, 1. Okay, so now we're just ready for letter C, part C. Let's do some inputs on either side of our vertical asymptote. Well, let's start on the right side. We know that, first of all, this graph is never crossing the x-axis. And apparently it skips over, because we have a hole, it skips over the point 2, 1. So really, I mean, you could do some inputs, but if we know that this graph section has to be contained in this area. It never crosses x, and there's a hole in the graph in this area, so that tells me that the entire graph is going to be in this area. But if you wanted to do an input, if you let's just say, for example, you chose 3 as an input, 1 over 3 minus 1, that would give you output 1/2. Okay, 1, 2, 3. I'm a little bit high, but that tells you again that your graph should be going through the point 3. And again, for these, don't change the origin. You're right back to the old-fashioned 0, 0. This is not a translation of a parent function. So input 3, output 1/2. I'm a little bit above it, but I'm pretty close. You can see there. So we're going to be, from there, we're going to be following this vertical asymptote forever, and then we'll be following this horizontal asymptote forever. Okay, that's what happens on the right side. Let's see what happens on the left side. So we can continue with our table. On the left side, I can use input 0. Okay, so let's do 1 over 0 minus 1. If I input 0, I get -1 output. So 0, -1 is on the graph. And that's really all I need, because again, I'm never, according to part A, I never cross the x-axis, no zeros. So I'm going to be going through this point, and I'm going to be following this horizontal asymptote forever, and then I'll be following this vertical asymptote forever. And we are done. I didn't fill in my table very well, but I can go ahead and say 3, 1/2. Those are inputs and outputs that we use. So that's it. And so that's the type of thing you're going to be doing on your test. Don't forget, sometimes people forget to put the hole in. They tell me where it is, but they forget to insert it. So keep that in mind. Okay, now we're in lesson 7.5. This is inverse variation. So the problem says, suppose x and y vary inversely. X is 14 when y is 3. Well, first of all, inverse variation looks like this in general. We have these two quantities, x and y. Inverse variation would say that I've got some number k that I'm dividing x into. So x and y are my two quantities that I'm comparing, and they have an inverse relationship. So inverse variation, you can always think of division. If it's direct variation, then you're going to be using multiplication times k. Okay? All right, so x is 14 when y is -3. I think I'm going to switch those around. It says x and y vary inversely, so I'll just leave them in the same order. All right, x is 14 when y is -3. So that tells me when I solve for k, k is going to be 14 times -3, which is -42. All right. We know now that our inverse variation equation is specific to this problem. It's -42 divided by y. Okay, so tell me, don't forget to do this on your test. Show me this equation and then actually use it for part B. Use the function to find y when x is -7. So -7 equals -42 divided by y. I can multiply both sides by y. And now divide by -7, and I get y is 6. Okay, so that's the way those work. You're going to have two parts. Give me the function after you find k, and then use the function to answer whatever part B is. Okay, number 10. Z varies directly with x and inversely with y. So this is an example of combined variation. So putting this in math terms, varies directly with x would be multiplication, and varies inversely with y would be division. All right, now let's take what we're given next and figure out what k is. When x is 2 and y is 3, z is 42. All right, so I'm going to replace all the variables in this expression except for k. X is 2, y is 3, z is 42. So let's see if we can solve for k. 42 times 3 is 126. And then when we divide by 2, we get k is 63. Okay, so what I'm going to do now is I started with this generic, in general, describing this first sentence, and now I'm going to make it specific using the value of k is 63. Okay, so that's part A. Should have done that up here as well. That's part A. This is part B. Part A is the function. Part B is using the function. Find z when x is 3 and y is 6. All right, so here's my part B. Find z if x is 3 and y is 6. So you could, since these are factors, 63 times 3, you can actually do some canceling here. You can make this become 1 and this become 2. So you have 63 over 2, which would be fine if you wanted to leave your answer that way. Or you could go to your calculator and make it 31.5. Well, there's the part B answer. Part A, part B. Okay, and here's an application problem involving inverse variation. The length of a violin string varies inversely as the frequency of its vibrations. All right, so I'm going to use variables L for length, F for frequency. That's my two quantities that vary inversely with one another. So using an equation to represent this, length varies inversely with frequency. Okay, so let's see. Let's take the next sentence so we can find out what this number k is that establishes the relationship, the inverse relationship. A violin string 14 inches long, tells me L is 14, vibrates at a frequency of 450 cycles per second. All right, so solving for k, we would do 14 times 450, and that's 6,300. All right, so now I know that for this problem, this will be the equation that I need to find either L or F, whichever one I'm asked to find, length of a string or frequency of vibrations. Okay, well in this case they want the frequency of a 12-inch string. So I take 12, I put it in for L. I've already found the K value is 6,300, and I'm solving for F. So I multiply by F on both sides. And my answer will be 6,300 divided by 12. 6,300 divided by 12. 525. Okay, and to put it into context, a word problem should be answered with words. It vibrates at 525 cycles per second. And there's your answer for number 11. Okay, and now we get to the last section of chapter 7, and that was solving equations that involve rational expressions. And so for these problems, we want to find the lowest common denominator again. And we're going to use that lowest common denominator to multiply on both sides. All right, so for number 12, the lowest common denominator is going to be 6x. So I'm going to multiply by that on both sides of this equation. And dividing 3x into 6x gives me 2. And then I multiply 2 times 9, that's 18. Over here, dividing 2 into 6x, that's 3x. And I multiply 3x times negative 6, and that's negative 18x. And pretty simply, I divide both sides by negative 18. And my final answer for this problem is x is negative 1. Okay, same thing over here. I'm going to find the lowest common denominator, and that's going to be 2q. 2q times q plus 1. I'm going to multiply by that on both sides to clear out the denominators. And if you want to, in this case, you're going to be multiplying 2 times all of this. So I'm just going to go ahead and multiply these together first. That's 2q squared plus 2q. And then that times 2. So I'm going to distribute 2 to both of these. That's 4q squared plus 4q. Okay, dividing 2q into this, the 2q's would cancel, and I'm left with q plus 1 to be multiplied by 5. That's 5q plus 5. This one, q plus 1 would cancel, and I'm left with 2q to multiply times 2q, and that's 4q squared. Okay, and my denominators are gone. I have no rational expressions, no fractions to deal with. So trying to get the q squares on the same side by subtraction, do you notice that they'll just cancel? And now I just can work on getting the two q terms together on the same side. So I'm just going to subtract 5q from both sides. That's negative 1q equals 5. And then dividing or multiplying by negative 1 on both sides, I get q is negative 5. And that's my answer for number 13. All right, moving right along. Need the LCD for number 14. I'm going to factor this denominator. And I'm going to use the, you could use the box method here. Again, 2x squared negative 3, that's negative 6x squared. And the factors of negative 6x squared that add up to negative 1x are negative 3x and positive 2x. So x and 1 plus 1, 2x minus 3 are the factors. And so that tells me that my LCD is going to be those two factors, 2x minus 3 times x plus 1. I'm just going to show it being multiplied on both sides. Okay, the 2x minus 3's would cancel, and so I multiply 4 times x plus 1, and that's 4x plus 4. The x plus 1's would cancel, and I multiply x times 2x minus 3, that's 2x squared minus 3x. Over here, both cancel, so it's like multiplying by 1 times negative 8x. Okay, looks like it's going to be a quadratic equation that needs to be solved, so let's combine like terms and make it equal to 0. So 2x squared. I'm going to go ahead and put these together. 4x minus 3x is 1x, and then if I add 8x to both sides, that makes 9x. And then I've got this plus 4. Okay, and you could solve by factoring, or if you wanted to complete the square or quadratic formula. I'm just going to do this by factoring. So I need the factors of 4 here, and could do the box method, but I'm just going to save us a little bit of time. If you do the box method, you will come up with this factoring. So my two solutions are setting each of these factors equal to 0, and I'm going to get negative 1/2 and negative 4 as solutions. Okay, and you should check and make sure that neither one of these makes 0 in any denominator if you plug those in for x, and neither one of them does that, so you're pretty safe. And if you got time on your test, I would encourage you to check those out. Make sure you didn't make a mistake along the way. Okay, here we are with another equation involving fractions. So we got to come up with the LCD, and looks like it's going to be 30x. And if you're not sure how I got that, you could do that prime factorization method that we looked at early on in this lesson. I think it was one of the early problems. So 2x goes into 30x, 15. 15 times 1 is 15. 5x goes into 30x 6 times. 6 times 4 is 24. So I brought down the minus sign. 3 goes into 30x, 10x, and 10x times 1 is 10x. 15 minus 24 is negative 9. Divide by 10 on both sides, and you get your answer is negative 9/10. Double check, make sure that that doesn't make 0 anywhere in a denominator, and we are good. Okay, now we have some review problems. Just don't want you to forget some of the older stuff that we've done fairly recently. This is a review of the square root parent. So I'm going to go ahead and just put the points for the parent function on here, 0, 0, 1, 1, 4, 2, 9, 3. So those points represent the parent. And there's really three things being done to this parent. Each of these 4 points are going to have these 3 things done to it. Okay? I'm going to list them out like this. For each of these points, the y coordinate only needs to be multiplied by -2. Okay, so let's start here. The y coordinate of this point is 0. 0 times -2 is still 0. All right, so far, multiplying by -2 on this point did not change anything. So I'm going to multiply y times -2. All right, then I'm going to go right 2. Remember, under the radical, this indicates a horizontal shift, and the horizontal shift is really tricky. It's the opposite of the way it looks. And finally, outside the radical tells me how to move up or down, and this is going to go up 1. So you put all that together, times -2, nothing, right 2, up 1, and I'll put my answer in red. So that first point that started at the origin, after I did all of these transformation processes, it's now this red point. So I'll just erase that one. And we're going to work through that for all of our points. All right, so here's my next one. The y coordinate here is 1, but when I multiply that by -2, it becomes -2. So notice how I changed from +1 to -2. And now I'm going to do the shift of right 2, up 1, and that's where my point is going to go. All right, so I started here, went to -2, right 2, up 1, and I'm going to make a dot. Having trouble with my pen. And I'll erase that one. We're done. All right. Okay, let's go to this one. This is 4, 2, y coordinate 2. But when I multiply 2 times -2, it turns it into the point 4, -4. Okay, now do the shift, right 2, up 1. All right, that one's done. And we got one more. This is the point 9, 3, but multiplying it by -2 turns it into 9, -6. Where'd my pen go? Okay, there's 9, -6, right 2, up 1. And I connect these, and this ends up being my graph. Notice it doesn't go in both directions. These square root parents, when x is positive, they're going to start at a beginning point, and they're going to go just to the right. And we're done. Don't have to do domain or range. Yeah, we do. Domain and range. Okay. All right. So let's use interval notation for the domain. It starts at 2, and 2 is included. So I use a bracket when the number is part of the domain. And it's going to go to positive infinity. You never bracket infinity. That means you're actually going to arrive, and you never arrive at infinity. Erase that point. Okay, so there's the domain. Now let's do the range. Now the range is going forever down, so we're going to come from -infinity. It's like we're coming from -infinity, and we're going to stop at y equals 1. And we're going to include 1 in the range. So that's it. We're done with that problem. And we got some log review on this review sheet. So let's take a look at these log equations. So for log equations, when you are presented with an equation that has more than one log of the same base, you need to combine those as one log. So we have a property called the product property that says when two different logs of the same base are being added, you can put those together as one log using multiplication. So I'm going to multiply a squared plus 3 times 3. 3a squared plus 9. All right, so I've accomplished turning two logs into one using the product property. Now I'm going to turn this log equation into an exponential equation. Okay, it looks like this. I take the base of the log, which is 3. I raise it to the power of 3. Just remember that when you're looking at a log equation, it's telling you what the exponent is. Logarithms are exponents. So I took the base, I raised it to the exponent. The only thing left is this 3a squared plus 9. It's going to have to go, to make an equation, it's going to have to go on the right. Okay, so this is 27. And now let's solve for a. So we subtract 9 from both sides. Divide by 3 on both sides. And I'm going to do the square root of both sides. And I'll be sure to tell you on the test if I want these to be exact answers. So this is what it means to be an exact answer. You just leave it as a simplified radical. Or if it says to round it to a certain number of decimal places, then you would just go to your calculator and type in the square root of 6 and round it accordingly. But I think I'll just leave it. Your answer on the answers that I provided on Moodle are in exact answer form. So I'll just go ahead and leave it like that. Okay, here's another example of two different logarithms, but this time they're being subtracted. So this is where the quotient property is used. Take two logs that are being subtracted and make one log using division. But after that, it's the same procedure. Take this log equation and turn it into an exponential equation. The base of 4 raised to an exponent of 1 is equal to this fraction. All right, and let's solve for y. So I'm going to multiply by 4y minus 2 on both sides, or sorry, y minus 2 on both sides. So I'll show my work here. That's going to cancel these, and that's going to give me 4y minus 8 equals 2y plus 2. Subtract 2y from both sides, add 8 to both sides, divide by 2 on both sides. And my answer is y equals 5. All right. On number 19, these are exponential equations, so I want you to see the difference. We ended up taking log equations and eventually turning them into exponential. In both cases, a log equation became an exponential equation. Well, just the reverse is happening here. Exponential equations or inequalities are going to become log equations. All right, so the first step here is to do log on both sides. Now I can use another property of logs called the power property, and it says you can bring this exponent down and turn it into a factor. And I can undo multiplication with division. Okay, and you'll need to go to your calculator at this point, and I'm going to pull up my Windows calculator, but you're going to do log 9 divided by log 5. And it looks like that is 1.3652, I believe. 1.3652. All right. And then to solve for x, you just subtract 2 from that. and you get negative 0.6348 after rounding. So let's say approximately. All right, there's your answer for number 19. Number 20 is similar. We're going to do log on both sides. So that we can use the power property and bring those exponents down. Okay. Now when you have the variable on both sides, you'll need to do the distributive property, with the goal eventually being getting the x's on the same side. So I'm going to distribute log 3 to both of these. And now I'm going to put my x terms on the same side. So I'm going to subtract x log 4, and I'm going to add log 3. Factor out x. And now you're pretty much ready to go to your calculator, because I'm going to undo multiplication with division. So in your calculator, you're going to divide log 3 by, and you make sure you put this denominator in parentheses. It'll look like this: log 3 minus log 4. And let me pull up my calculator. So hopefully with your calculator you were able to get negative 3.8188. And I just want to point out something that is easy to miss on these problems. If you notice, we're dividing by log 3 minus log 4. Well, if you just look at that as, if you didn't have logs involved, you would have 3 minus 4, which would be negative 1. Well, log 3 minus log 4 is also going to be a negative number. So here we have that rule of division by a negative number is going to cause us to have to switch or reverse the direction of the inequality. So this is going to change from less than equal to greater than or equal to. So you really have to pay attention when you're doing this type of log problem. Notice if the left number is smaller than the right in your log subtraction, then that's going to result in a negative number. Okay, so we're ready to finish up our last two problems. We have a natural log equation, and then we have an e raised to the power equation. So the rule, it goes like this. These natural log equations eventually are going to be converted so that they are e to the x. So this equation on the left is going to look something like this, and then we're going to go to our calculator and let it do the rest of the work. And these equations, where I have e raised to a power, are going to be converted so that they look like this. So it's good that we have these two side by side, because really our goal is to turn this one into this and vice versa. So before I can turn this natural log equation into an e raised to the power, some power equation, I need to take care of numbers that are being multiplied times the log, and that's easy enough to do. In this case, just divide by 5, and I get natural log 6x is equal to 8/5. Okay, now I'm ready to convert this. This is a natural log, so in other words, natural log means base e. It's not, but could be thought of as log base e of 6x equals 8/5. Well, when e is the base, we use the natural log notation. But this kind of helps us see what this would look like in exponential form. E is the base. The exponent for the logarithm is 8/5, or the exponent for e is 8/5. Remember, logarithms are exponents. So I do e to the 8/5 power is equal to 6x. All right, now you go to your calculator and plug in e to the x power, use that button, and make 8/5 your exponent. Okay, and then after you've done that, you divide that result by 6, and your final answer here after rounding is 0.8255. 0.8255. Okay, all right, one more to go. So this is an exponential equation where e is the base. So once again, just to repeat, we're going to turn this into a natural log equation so our calculator can do most of the work. Well, in these problems, you need to isolate e to the x. So we got 2 steps. We're going to add 3, and then we're going to divide by 6. And I'll just go ahead and reduce 38 divided by 6 is 19/3. Okay, well, just notice how we went from natural log to e. Well, now we're going from e to natural log. So remember, we're going to do natural log of 19/3. And since logarithms are exponents, always let your log equal the exponent. Okay, go to your calculator, and this time you're going to use the ln feature, the natural log feature. So do natural log 19/3, and you're going to get 1.8455. 1.8458, sorry, 1.8458 after rounding. Okay, and that is it. And I hope this helps you get ready for this coming test. And if you still have questions after watching this, feel free to reach out to me, and I'll be glad to help you. I'll see you next time.